coming up very soon, so make sure you get your homework done this weekend. If there's anything that needs finishing or completing, it is due by test day, okay? So make sure you get anything done that needs completing. All right, so today we're using law of sines, or learning law of sines. We want to be able to figure out sides and angles using law of sines, which turns out to be pretty easy. So far, we've been using all of our trig ratios to find sides and angles of right triangles, which is key. Trigonometry is the study of right triangles, but it turns out it's not too hard to figure out relationships for non-right triangles. So law of sine shows the relationship between angles and their opposite sides, and it can be used to find lengths and angles of any triangle, which also might be called oblique. All right, oblique triangles are non-right triangles. So you don't have to have a right angle, and we can still apply the law of sines. So given triangle ABC, it turns out that the sine of the angle over its opposite side, so we do sine of capital A, we use capital letters to represent the vertices of a triangle. We use lowercase letters to represent their sides, the opposite sides. So you'll notice here, angle A has its opposite side as lowercase a. And if you're looking from angle B, its opposite side is lowercase b. All right, so there's really hardcore notation going on in this law of sines here. So the sine of the angle over its opposite side is equal to the sine of another angle over its opposite side. And also the sine of the third angle over its opposite side is also going to be an equal ratio. So all of these things turn out to be equivalent, and we can pick and choose which two we're going to use to create an equation to solve. And how are we going to solve this? How do you solve a fraction equal to a fraction? Cross multiply. Every time. All we do. All we do in geometry is cross multiply. All the time. All right, so let's give it a try. Use law of sines to set up a proportion and solve. So here I have my angle of 71 degrees and I have my opposite side of x. I have my angle of 35 degrees and I have an opposite side of 12. So it's important that you have your angle and opposite side paired up. And if you've got your pairs, then I can write my proportion. The sine of my 35 degree angle over 12 is equivalent to the sine of my 71 degree angle over x.
Can we also put them as like a and uppercase A and lowercase a? So like 71 would be uppercase and the x would be lowercase.
71
would be the uppercase A, and then x would be a lowercase a.
It's a side.
Yeah.
Yeah. And it, yeah. All right. How do we solve for x? Yep, cross multiply. So we're going to multiply x times the sine of 35 degrees equals 12 times the sine of 71 degrees. Be very, very careful that we're not multiplying 12 times 71. 71 is trapped inside the sine, so you don't want to multiply those numbers together because there's this whole sine function surrounding the 71, okay? So we usually just write the number in front. How do you get x by itself? Divide by the sine of 35. Divide by the sine of 35 degrees. So sine of 35 cancels out. We get x by itself. and we can go to our calculator. What mode are we in?
Degree.
Degree mode. How do we know that?
Top right.
Oh, it's on our calculators, it's the top right, true. But we know we're using degrees because we're given angles in degrees. Degree symbol? Okay. Good, good, good. So 12 times the sine of 71 is on top, and then I'm just going to divide by the sine of 35. Oops, I don't need the double parentheses there. All right. So you can type it in just like that. 12 times the sine of 71 divided by the sine of 35. All in one line. Very nice. Let's round to the tens place. What would we round to?
17.8 or 19.8.
19.8. And that would be 19.8 units, whatever they are, if they're inches or feet. All right, let's look at they're all the same. Like it doesn't. All right, let's do number 4 because number 4 is different. All right, let's see. On number 4, I have my angle, and what's its opposite side? 27. Okay. And then I have 53, and what's its opposite side? Unknown. We don't know. You are right, sir. Which means I can't use 53 because I don't have information about its side, okay? The x is right there, though, so I can't put in another x. So that's the x we're trying to find. And if this is the x I'm trying to find, then I need to know this angle measure, all right? This is the x I want to know. I need to know that angle measure there. How can I figure out that angle measure? Subtract from 180. It is a triangle. So 180 minus 53 minus 96 is 31 degrees. So yes, it is still a triangle, and we can still subtract to find our missing angle. And now we can set up our sine, law of sines proportion. So I'm going to write the sine of my angle 96 over its opposite side 27 is equal to what over what? It's not a sin.
You call it.
It is not a sin. It's sine.
You're a sin.
No.
Sine 31.
Sine of 31 degrees over x. Thank you very much. Okay. All right. How do we solve for x? Cross multiply. So we get x times the sine of 96 degrees equals 27 times the sine of 31 degrees. And then how do you get, hey, how do we get x by itself? Divide the sine of 96. All right, type it in your calculator. Tell me what you get. All right, what did you get? 0.5. Nope, that don't sound right. The side length is 27. 0.5 sounds really small. 13.98, yeah. Which, if we round to the tenths, what does that round to? 14.0, yes. All right. All right. Will you please do number 6, please? Do now number 6. Do now number 6, all by your lonesome.
That's 11 minutes. 12 minutes. From 05.
He said he's going to be here at 15.
You know,
17.
He's going to be here in 13.
Yeah, what about yourself, man? All right, you're working on number 6. this angle. Okay. Figure out your missing angle. Obviously. All right, hopefully you're almost done. But once you figure out your missing angle, which happened to be 89 degrees, then you can set up your ratio. Sine of 89 over x equals sine of 58 degrees over its opposite side of 25. Does it matter if you wrote it in this order or if you switched it around? Doesn't matter. Okay, so if they're swapped, and that's the symmetric property. Okay, I do want to say that in Delta Math they're using maybe triangle JKL. What should you do if they give you a triangle like this, but they don't give you a picture? Draw one, absolutely. So you can draw any triangle you want. You're going to label J, K, and L. And what would lowercase j be? What would lowercase j be? Yeah, lowercase j is the side opposite the angle of capital J. And then lowercase k is the side opposite big K, all right? So the lowercase is always opposite its capital letter, okay? So draw your picture, label it, and figure out where things go. The solution for x here was 29.5, so good job if you got that right. Okay, questions on this setup for law of sines? Okay, it's super easy. Let's turn the page. So we can also use it if we want to find an angle measure pretty easily. Once again, we have an angle and its opposite side. That's good news. I want to find an angle, but I have information about its opposite side. And so again, if I have my angle and opposite side info, I can write a proportion. Sine of 77 degrees over 14 is equal to sine of x over 9. All right, what should we do? Cross multiply, sure. We are going to cross multiply. Let's see, I'm going to write my 14 times the sine of x first. And then I have 9 times the sine of 77. All right, what do you think we should do next? I have to divide by something. Yep, that's a good start. We got to get rid of the 14, so we're going to divide by 14. So those 14s go away. And that leaves me with the sine of x equals all that stuff, 9 times the sine of 77 over 14. Now, I'm trying to get at the x, but right now it's trapped inside a sine function. So how do I get rid of the sine function? Inverse, yes. We're going to take the sine inverse of both sides. So again, the best way to do this is smush it in. The sine inverse and sine undo one another, freeing the x. And all I have to do is type this portion in my calculator right here. So I'm going to do sine inverse of 9 sine of 77 divided by 14. You can put it all in one line. Make sure that you close your parentheses so that you're taking the sine inverse of the entire fraction. And we get 38.8. What are the units on here? Degrees, yes, because we found an angle measure. X degrees. All right. All right. Let's try number 10. Do I have an angle and opposite side info? Okay. So I got 126 and its opposite side is 31. I also have the X here and its opposite side of 15. All right. So I have sine of X over 15 is equal to sine of 126 degrees over 31. Sine of your angle over its opposite side. And then we're going to cross multiply. So that gives me 31 times the sine of X equals 15 times the sine of 126 degrees. Then what should we do? Divide the 31. Divide the 31. So the 31 is gone. I'm left with the sine of my angle X equals 15 times the sine of 126 degrees over 31. And then how do you free the X? Sine inverse of both sides, sine inverse. Sine inverse. Again, I really encourage you to smush it in, use those parentheses. This is 100% mathematically correct. And then you can just type in this whole thing. Sine inverse of 15 sine of 126 divided by 31. Is anyone not getting, I do want you to practice putting this in your calculator. Please try it in your calculator. You'll notice I closed my parentheses on the 126 to make sure the calculator understands I'm taking the sine of the 126 degrees and not the sine of 126 over 31. Okay? Really important that you tell the calculator, I just want the sine of the 126. And I got 23.0 degrees. All right. All right, how do you feel so far? Are you good? All right. All right, I guess we're okay. Do we need another one of these, or you got it? You got it? All right, cool. Great.